Welcome back to the Tech Talk podcast, everyone. I'm super excited to dive into today's topic, which revolves around some cutting-edge developments in the field of computer vision and object detection. We'll be discussing a fascinating new approach called DEFINE, or Fine-Grained Distribution Refinement, which promises to redefine how we tackle the regression task in the context of DETR, detection transforms. So what exactly is DEFINE? In simple terms, it's an innovative real-time object detector that improves the way bounding boxes are handled when pinpointing objects in images and videos. You know how when you're trying to take a picture of your dog, but it moves just as you press the shutter? It's tricky to get that bounding box around a moving target, right? DEFINE aims to smooth out these challenges by refining the bounding box predictions through a fine-grained approach. This method utilizes something called Global Optimal Localization Self-Distillation, or GO-LSD for short. Now, I know that sounds a bit complex, but it basically means that DEFINE learns from itself during training. Imagine you're in a classroom. One of the best ways to learn something is to teach it to someone else. In this case, DEFINE marks its predictions and then goes back to refine its earlier assumptions based on its final output. It's like revisiting your homework with a teacher's feedback, and that leads to better results. What's really impressive is that DEFINE doesn't come with additional costs in terms of sequence inference or training overhead. It's efficient and incredibly effective. In fact, in tests conducted on complex street scene videos, DEFINE managed to detect almost all targets, even in situations with challenging light conditions or motion blur, conditions that usually throw many object detectors for a loop. So why is this important? Well, if you think about various applications, from self-driving cars to smart surveillance systems, precise object detection can make a world of difference. Speaking of applications, DEFINE's performance metrics are quite impressive too. It has shown remarkable precision in localizing objects that are typically tough to spot, such as small items like backpacks and bicycles, even in crowded or poorly lit environments. And it seems to do better than its predecessor, the YOLO model, particularly regarding confidence scores and the detection of blurred edges. That's like saying it's not just good at spotting your dog in a park, but it can even tell which way it's looking. Now, for those interested in the nitty-gritty technical details, DEFINE comes with various models, such as DEFINE X, which has achieved a 55.8% average precision on the COCO dataset. You might be wondering, what's COCO? Well, it's a large-scale object detection dataset commonly used to benchmark the performance of object detection algorithms. It's like the Olympics for AI models. Everyone wants to bring home a medal. Before we wrap things up, let's think about the implications of such technology. What does a better understanding of object localization mean for the future, especially as we move into more integrated smart technologies? How might this affect our daily lives? Could it lead to more reliable AI in our homes, or even safer autonomous vehicles? As we sign off, remember that advancements like DEFINE are only just the beginning. The future of object detection will likely bring even more exciting changes. If you found today's conversation intriguing, keep an eye out for future developments in this space. Thanks for tuning in to Tech Talk. If you enjoyed the episode, feel free to subscribe and share your thoughts. Until next time, keep exploring the wonders of technology.